So next up, we have our final remote team. I really don't know what to say about these guys. They call themselves the Mad Scientists, and I think it's a suitable moniker. So I like their app. It really demonstrates the general purpose nature of JavaScript. So their product consists of a web application, a React Native mobile app, and a hardware app, all connected to each other. And what's impressive is not just that they successfully created these three separate apps, but they collaboratively built the hardware application in the last 2.5 weeks or so, only meeting for the first time in person yesterday.
Wow.
So we had an electrical engineer in India, we had 2 people working in New York and New Jersey, and then someone out in California, all working on basically what is a hardware product.
Wow. By the way, that sounded exactly like Steve Jobs' introduction to the iPhone.
I was going to push it a bit.
Very high.
Do you get it? All right. So I would love to introduce to you the last remote team. It is Mart.
Thanks, John. Hi, I'm Shmuel Lotman, and I'm here with my teammates Suyash Chopra, Trey Cooper, and Raymond Torres. Together, we created Mart. The human experience is one of innovation and improvement. As a people, we thrived when we challenged the status quo and questioned the way we do things. As we deliberated over the direction of our project, we discovered that one of our most central activities had been left virtually untouched since its inception: shopping. Our project, Mart, seeks to revolutionize one of our most basic and common experiences, creating an easier, safer, and faster alternative to the arduous processes of today. Utilizing facial recognition software powered by the Kairos API, a seamless integration of mobile and web apps with Socket.io live update data feeds, and a React Redux Express SQLite stack, we created an application that brings shopping into the digital age. Welcome to the end of lines, as you know them. I'm now going to pass it off to my teammate Ray, who will present a demonstration of our application's complete functionality. So, without further ado, Ray, please take it away.
Thank you, Shmuel. So first, let's sign up. Suyash is entering his account information and taking some photos. Once he has some good shots, he's ready to go. Shortly, an entrance camera will track the user's face as they walk in, and they're greeted by Mart.
Hello, Ray. Welcome to the store.
We have our mobile app on the right and admin app on the bottom being updated in real time as users enter the store.
Hello, Suyash. Welcome to the store.
Suyash now proceeds to make his first item purchase, and we have the sensor programmed to detect how many items have actually been grabbed. At the same time, another camera takes a photo to ensure the correct user is charged. As you can see now, you can even put items back, and the sensor has been designed to intelligently detect the distance between products and adjust the quantity of the items you grabbed accordingly. After walking out, exit camera captures the user one last time. We then charge your card on file and send you an email receipt. If you view your order history, you'll see a dispute button in the detail screen so you can dispute any errors that might have been made. Thank you, and now I'm going to hand it off to Suyash for an architecture breakdown.
Thank you, Ray. For this project, we divided the entire architecture into 3 main components, which consisted of the hardware, the mobile application, and the admin client service layer. As Ray mentioned, we have 3 clients: the camera, the admin, and the user. They are all plugged into the central server that maintains the store's information. The differential camera engine helps to monitor users on the entry and exit. For facial recognition, we used Kairos, an API which stores user images and connects information to our own database via foreign keys. With the server running most of the store and no employees, we felt that it was very important for the owner or the administrator of the store to have complete control over the security in his or her store as to what people were buying. The live update that power this functionality and the cart for the users are enabled via WebSockets. The ultrasonic sensor that connects to the Raspberry Pi detects the distance and the change when a product is picked up and dispatches an action to capture an image of the user. And now I'll pass it off to Trey.
Thank you, Suyash. Mart was built in a few weeks with a small budget by a remote team with members working in 2 different continents. These constraints posed many challenges along the way. However, Hypermodularity allowed us to test every moving part individually so that when we met in person, all we had to do was connect everything over the same network. With increased resources, the concepts proven here could truly bring us to the end of the line as we know it. Thank you.
All right, if you don't like grocery lines, feel free to vote for Smart Mart. Like the post, like the pinned comment. That was really cool. It was really it was very much, I couldn't tell if I was watching a student project or like a Silicon Valley pitch presentation. But
I think that was reasonably rivaling the iPhone introduction, and so
yeah,
I have to give it to the team. Yeah, that was great.
Yeah, the demo looked pretty cool. It was like walk in. I don't know that much of the Kairos API, but they seem to have integrated well into the functionality of the.
I wonder if we could at least use that for attendance.
Yeah, that'd be nice. Instead of.
I got to work with these students for the first 6 weeks, the remote cohort, and so incredibly impressed with all of their projects.
Yeah, those are some really great projects. I'm very impressed by all of them, by the breadth of the type of stuff they chose to work on.